Hi, in this video we'll be covering the constant chain of replacement method that's discussed in Module 3 of the CPA Australia's FRM syllabus. So in Module 3, this is on financing and evaluating investments. So when we are comparing projects of different lives, one of the method that allows us to compare different projects with different lives, it's this constant chain of replacement method. Now, to illustrate this method, we'll look at one example, which is Project X here, with 4 years life. Okay, and it generates cash flows throughout that 4 years. So it requires an initial investment of $80,000 at the beginning, followed by cash inflows of $20,000, $30,000, $60,000, and $40,000. Now, using a 12% discount rate, the NPV computed for this project is $29,501. Now, it's a positive NPV, okay, and in this case, it will be accepted in most cases, okay. But let's say if there is another project, okay, that has a 3 years life or 2 years life or maybe 5 years life, then we can't compare the NPV of those two projects directly, okay, because their lives are not the same. Now, in order to illustrate this constant chain of replacement method, okay, so for Project X, we'll be doing 3 steps, okay. First, we'll have to calculate the present value annuity factor for this 4 years project, and then we'll calculate the EAA, okay, which is the equivalent annual annuity, and then from there we'll calculate the PV of this perpetuity. Now, first step to calculate the PV or the present value annuity factor. This is a 4 years project, so first step to calculate the present value annuity factor. So the formula for the present value annuity factor is 1 over R. R is a discount rate in this case. Then we multiply by 1 minus 1 over 1 plus R to the power of n representing the life of the project. So the discount rate here is 12%. So we'll substitute 12%. And this is 1.12 to the power of 4. Okay, the project's life is 4 years, and then we'll compute this on your calculator. So here we have 1 divided by 0.12 multiplied by 1 minus 1 divided by 1.12 to the power of 4, close bracket. So that's equals to 3.0735. Next, we're going to calculate the equivalent annual annuity. So to do that, okay, so this is the equivalent annual annuity. So the EAA here will be computed by taking the NPV of the project, and then we divide by the present value annuity factor. So the NPV in this case is $29,501. And then we divide it by 3.03735, which we computed earlier. So that would be equals to $9,712.74. Now, this would mean that if Project X can be repeated forever or indefinitely, then this project would generate an annuity of $9,712.74 every year. Okay, so to illustrate that, it means that every time we repeat this project, we're going to get this number in year 1, okay, and also in year 2, year 3, and until infinity. Okay, so we're going to get this number forever. So what would be the PV or present value of this perpetuity? So to calculate the PV of the perpetuity, the formula would be to take the annuity amount, which is 9,712.74, then we divide by the interest rate. So that will be equal to $80,939.50. Okay, so this is the PV of this Project X if it is repeated forever. So you have to know how to calculate the equivalent annual annuity. Okay, this would be the more critical component. So whichever project generates the higher EAA or higher positive EAA would be the preferred project. Or if you convert this into the PV of a perpetuity, then the higher PV, positive PV, would be the preferred project.